In this session, let us see how the subgrade will be constructed. Subgrade is the portion of the road pavement which act as a foundation for the payments, and once the subgrade is constructed, that should be conformed with the lines, grades and the cross section that has been indicated in the plans. The typical cross sections of the subgrade is as shown in the figures here. The subgrade can be taken either on the in the embankment portion if the original ground level is at the lower elevation the compared to the required elevation of the pavement. So generally the payments will be taken on the subgrade. If the elevation of a ground is at the higher elevation compared to the required ground profile of the pavement, so here the cutting has to be done and subgrade has to be taken at the cutting. In fill section, subgrade will indicates the top of the embankment or the filling that we have done, and whereas at the cutting, the subgrade will act as the bottom of the cut. The subgrade supports the base and subbase layer and all other layers above the pavement. So to ensure the stable, long-lasting and maintenance-free roadway, the subgrade is to be constructed using a certain procedure and has to be constructed as per the guidelines given. Let us see how the pavement subgrade will be constructed. The construction procedure involves, the first will be the setting out. In the setting out, first we have to establish the limits of the embankment and what is the bottom width, how much should be there, total width of the embankment that are marked by fixing the batter or pegs on the both sides at some regular interval. The subgrade should be generally wider than the design dimension so that the surplus material can be trimmed off later stages. The next stage will be the dewatering. So dewatering is required in those regions where the groundwater table level is at the higher elevation. The code says that the groundwater table must be 1.2 meters below the subgrade level. If in case where the groundwater exists at the shallow depth, the dewatering must be done by installing the suitable method has to be installed. So you can see here through the pipes they are dewatering the water that exists at the to bring the groundwater level to the lower elevation. After the dewatering is done, the stripping off and stripping of the topsoil has to be done. So here on the vegetation, whatever it is there, that has to be removed. Okay, and the topsoil from those area has to be taken out, and generally at a depth, the top 150 mm of the soil will be removed so that there will not be any vegetation growth at the later stages. And the soil which has been removed here, the topsoil, that will be stored in a stockpiles of height not exceeding 2 meters, and this will be used for covering the embankment slopes. Then the compacting of the existing ground must be done wherever it is necessary. It has to be first the layer has to be leveled and it has to be compacted. So here you have to note down that if required, the water has to be spread so that to achieve the OMC condition, and compaction will be done such that you will achieve maximum dry density. So how much compaction is preferable? In case if the soil subgrade and the ground level is less than 0.5 meter, the ground does not have the relate 95% of compaction, then the ground has to be loosened up for top 0.5 meters below the subgrade level. It has to be watered and compacted in the layers not less than, and the density achieved must not be less than 97% the dry density. So here you can see that the codal how much the compaction has to be done. All these values has been recommended by the MORTH specification. So the density requirement of embankment and subgrade material. So depending upon the type of the work, you have to get the minimum required lab density. If the embankment is up to height 3 meters and not subjected to excessive flooding, the laboratory density obtained should not be less than 15.2 kilonewton per meter cube. And similarly, for various condition, what should be the lab density for the material is given. And at the field, when the compaction is done, for the subgrade and the earthen shoulder, the relative compaction should not be less than 97%, and if it is for the embankment, the relative density must be not be less than 95%. And similarly, for expansive soil, the compaction rate should not be less than 90%. So it means to say that whatever the lab density we get here, after the compaction is done in the field, you have to check with the suitable material method what is the field density you have obtained. Compare the field density with the laboratory density. Field density by the density obtained at the lab into 100 will gives you the relative compaction. So when you compare the density obtained with the lab in the field along with the laboratory density, so that should not be less than these recommended value. The next we'll move on how the embankment will be constructed or the subgrade will be constructed. First is embankment or subgrade material has to be spread. The subgrade has to be taken on the embankment, and the soil it has to be spread in the uniform thickness. The thickness of individual layers should not be more than 200 mm once it is compacted, and the soil has to be spread to the entire width of the embankment by the mechanical means. You can use the mortar grader, and then the compaction will be done. And before the compaction is achieved, we have to check for the moisture content. So before prior to the commencement of the compaction, you have to check the moisture content using any of the suitable moisture content determination test. Field moisture quick test can be done. Either the calcium carbide method is the one suitable one, or if the water content of the subgrade soil which has been spread, if it is not corresponding to the OMC value, then the additional water must be sprinkled from a water tanker, and it has to be mixed evenly. Again, the moisture content has to be checked. Field moisture content should be in accordance with the table 1 of the IS 2720. If any clots or hard lumps are there, that has to be broken. And when the embankment is constructed, so that hard lumps should not have the maximum size exceeding the 75 mm, and the same the lump size should not be more than 50 mm when it is placed in the subgrades. When the embankment is constructed, it has to be taken care that there should not be any steeper side slope or the greater width of the embankment. When the fill is deposited, you have to ensure that the slope steeper than 1 in vertical to 4 horizontal. It has to be benched. Generally will keep the slope of the embankment as flat as it is possible. Once the spreading of the material is done, then the compaction has to be done. Compactions can be done using smooth wheel roller, vibratory roller, pneumatic tire, sheep foot, or the pad foot roller, depending upon the size and the type of the soil that is need to be compacted. The compaction will be done with the vibratory roller of 80 to 100 kilonewton static weight or heavy compacted tritoner when we are using the granular material. So each layer must be roughly compacted as to the density requirement as we have saw in the earlier, and the subsequent layer should be laid only after finishing the first layer. So after the completion of each and every layer, so we have mentioned that thickness of individual compacted layer must not exceed 200 mm. So once the first layer has been compacted, then the field density test has to be done, and we have to check the relative density. If the obtained relative density is not in accordance with the table which we mentioned earlier, then the further compaction has to be done before laying with the next layer. After the compaction is done, the subgrade has to be left for 2-3 monsoon so that any consolidation is there that will occur. And in the next stages, the repair of damage caused by the rain or spillage of water has to be removed. The soil in the affected portion has to be removed by before the next layer is laid and refilled in the layer compacted using a small vibratory roller or plate compactor or power rammer can be used to achieve the required density. And the last, the finishing operation has to be done. The work includes the shaping and dressing the shoulders, verge, road buds and the side slope to conform to the alignment and the cross section and the dimension as per the plan. Both the upper and lower end of the road side slope shall be rounded off to merge the embankment with the adjacent terrain and improve the appearance. The topsoil must be removed and conserved. Earlier shall be spread over the fill slope. Before spreading, the slope should be roughened and moistened slightly to provide a bond and is provided at a depth of 75 mm to 150 mm for a plant growth. When the earthwork is completed, the road shall be cleared of all the debris and the ugly cars. Next is very important thing, after the road construction is done, you have to check for the quality control test. So some of the quality control check that are done for the subgrade or include the sand content has to be checked. So the frequency of the test has been included. So 2 tests per every 3000 cubic meter of the soil, and the soil has to be tested for the plasticity index, density and deleterious materials if any. And is also this content, deleterious content will be checked as and when it is required. And compaction has to be tested very frequent at the frequent intervals. At least one measurement has to be taken. At least one measurement of compaction test has to be done for every 1000 square meters of compacted area. The test location must be chosen based upon the random sampling. The control should be based upon the mean value of 5 to 10 density determination. For earthwork in shoulder, at least one density measurement has to be done for every 500 square meters for the compacted area should be made. The number of tests in each test shall be at least 10. So now you can see here at the field how the compaction control test can be done. The most popularly used method for the checking the density of the soil at the fields are including the core cutter method and the stand replacement method. Any of these two methods can be adopted depending upon the type of the soil that has been used in the construction of the subgrade. Now in the image here you can see here the person is taking the sample using the core cutter method, and here these are the test apparatus which will use to check the density or moisture content determination. So at the frequent intervals, as we mentioned earlier, if you are doing it for the embankment, it has to for every 500 square meters of the compacted area we need to take one measurement, and if it is for the subgrade, for every 1000 square meter of area we have to take one measurement. Okay, and we have to take at least 5 to 10 sample measurements, and the mean value of it will be represents the field density obtained. In the coming classes we'll discuss how the other payment layers will be constructed. Thank you.